So my next guest today is Grace O Malley from iNEMI. Great to see you, Grace. Thank you for coming in.
Thanks, Trevor.
Yeah. So let's start off with iNEMI. Of course, you're very well known for the roadmaps. When can we expect the next one, and what's the current status?
Yeah, current status. Well, we've changed our format. Rather than publishing a roadmap every 2 years, we now have a rolling publication of key topics in electronics manufacturing. So that's very much based on input from the industry on areas that they're looking to roadmap. So most recently, we've published updates to our printed circuit board roadmap. So that's very relevant to the audience here at IPC Apex. And we'll have a session actually here this week, tomorrow morning from 9:30 to 12, which will look at some of the key messages and key kind of highlights coming from the roadmap. Also input from some of the project work that we do, which was based on earlier versions of the roadmap. And then a discussion group for areas that the industry might like to see us roadmap in the future.
Right.
So one of those, for example, would be, the impact on sustainability and environmental reporting on the printed circuit board industry, right? Because everyone along the supply chain is seeing the need from their customers and ultimately from the marketplace to increase their understanding of their resource usage and resource efficiency, and also to be reporting that to their customers. So potentially that may be one of the areas that we'll work on in the future, as many deep technical areas such as CAF and mitigation and hybrid printed circuit board, some of the challenges there, and the impact still of the move to higher frequency applications, the impact on the materials and the design and the performance of printed circuit boards.
Printed circuit boards, okay.
Yeah.
And you also cover obviously lots of areas in PCBA. You're looking at conformal coatings and that sort of thing, and also into the advanced packaging side. So there's lots of different areas and lots of different things coming into under that umbrella. For example, you're in the advanced packaging side, we're starting to see a bit more photonics coming into that side of it.
Yeah, very, very true. And in fact, we're seeing that convergence, right? Light is now needed, right? Electrons can't take us everywhere we want to go in the future. So you're seeing it being deployed in the high-speed application spaces and certainly in data centers. It's been used for a long time, right? So actually iNEMI has had a long history of working with the optical connector community and looking at some of the enablers to introducing new technologies into the industry. So the cleanliness requirements that are needed, understanding the material sets and the testing, inline testing in data centers. And most recently, we've just started a project looking at the impact of immersion cooling on the long-term performance of optical connectors and other optical components that are in data centers.
This is the liquid cooling systems that they're putting on top of these assemblies.
Yeah, and that's obviously with the unprecedented growth, and probably I shouldn't say unprecedented, but unforecasted level of growth in data centers around the world. The data centers are looking to improve their performance and ultimately improve their efficiency of the data centers and their energy usage, right? So they're looking at all aspects, and immersion cooling offers a lot of solutions, but of course all the electronics has been designed to operate in air, right? Maybe warm air, but definitely in air. Now we want to put it in any type of liquid for any length of time. So we need to understand the implications of that, at a chemical level, a physical level, and also develop test methods that the industry can use to qualify future materials, either the liquids themselves or the materials that you would use in the optical components. And we hope to start another project that will look then on the electrical performance. This one is concentrating on the optical performance, and is there any adverse impact over time on the optical performances due to immersion in a variety of different chemistries. But in the future, we'll look at the impact on the dielectric constant and electrical performance of the materials.
So. Because the expectation is that these things are going to last at least 6-8 years.
Yes. Now, typically in data centers, they churn the boards out pretty quickly. But again, everyone is looking to increase their efficiency, prolong their lifetime. We invest a lot of money, time, and effort in the systems we're putting into data centers. So we want to ensure that we do them. And they don't want to go pulling things in and out on a regular basis. So yeah, they're probably looking for a couple of years.
Right.
But again, there's no standard for that right now.
Right.
So, and we need to understand what accelerated life testing we might need to start deploying and standardizing across the industry to look at that.
So looking at the advanced packaging industry in particular, you know, I mean, it's evolving with materials, different materials, you know, silicon, carbide, glass, etc. The miniaturization is getting worse, getting smaller. But do you see advanced packaging as being the answer to Moore's law going forward?
Well, I certainly see it as a key enabler to addressing the limitations of Moore's law, right? Because the devices, as they are right now, presently can't go any further. But by deconstructing and redesigning the system and leveraging packaging capabilities, you can achieve the functionality that you want.
Right.
So it's a very interesting time in the packaging world, right? We're getting to work with a wide variety of devices, and as you say, you know, integrated sensing capabilities, optical capabilities as well, to give the additional functionality. So certainly, I think packaging technologies are a very interesting space at the moment. A lot of development worldwide going on, but in all the ecosystem that supports that. So the design tools, the materials, the assembly equipment, test, extremely important. And all driving to achieving ultimately performance, but to ensuring high yield that makes it cost effective. So that's probably a real focus of the type, at least the part of it that iNEMI contributes to, is looking at how you can make improve the yield resilience, right, in any of the processes that you're doing. Yeah.
Well, I guess, you know, when you talk about yield and testing and that at the semiconductor level, you know, the sooner you can detect the known good die, you know, the less money it's going to cost you in the process.
Yeah, very, very true. Very true. And I suppose those are some of the advantages of being able to pick and choose early in the process. But again, if you're creating, say, a chiplet package architecture, you're having to combine maybe devices with completely different material sets, metallization sets, different design rules, and you're trying to put them on a common substrate or some form of common substrate across them. So there's still a lot of other challenges that need to be addressed, including standardizing maybe layout and design for the majority or for the commodity applications, most definitely, and also the finish that you might have on the the chips that are being bonded and on the substrates as well, so that you can ensure that you're getting consistent high yield and you're not having to have too many additional interconnect processes in the system.
But the answer to be able to do that really is going to require more standardization.
Definitely, and I think input from everybody along the supply chain in developing those standards, right? So that is everybody from the design tools, through to the device, materials, and the packaging test, and ultimately the system integrators at the end, right? You have to always look at things from a system integration perspective, and we're only making more and more complex systems as we go ahead. So to be successful and to ensure that you get the performance you want, the lifetime you want, and all the relevant data communicated to all the relevant people securely along the supply chain is quite complex. So we need to work together to do that.
Absolutely. Well, I mean, I think iNEMI does an enormous job and a very high level as well, I might say. So it's a great contribution to the industry. But I mean, there's no shortage of things for you to be working on.
No, very true. In fact, we will celebrate 30 years next year in 26, and I think it's a proof that the industry does want to work and collaborate in many different areas, right, on common needs and problems, because we're still working, and there are always new areas and that we're being challenged with, and it's wonderful to work with some of the leading thinkers and researchers in electronics manufacturing from around the globe.
Yeah, absolutely. Well, Grace, it's always great to catch up, and I love to hear about all these new projects you keep doing. So thank you for coming in and telling us about it today.
Thanks very much.
Video proudly sponsored by Kil Young Technology. True 3D inspection for the SMT industry.